A train speeds past a pole in 15 seconds and a platform 100 meters long in 25 seconds. What is the length of this train? Well, let us keep the length of this train as x meters. Now this train speeds past a pole in 15 seconds. So the time taken to travel x meters is given, which is 15. And it is equals to the distance upon speed. The distance is x meters upon, let the speed be s meters per second. Right. Now, what else is given to us? This train also speeds past a platform which is 100 meters long in 25 seconds. So we have 25, the time is equals to distance upon speed. The speed is same, which is s. What is the distance? Well, the distance is the length of the train as well as the length of the platform, which is x plus 100. So we have two equations. Let us solve this equation first. We have s is equals to x by 15. And on the right hand side we have s is equals to x plus 100 by 25. So we can equate the two terms on the right hand side. We have x by 15 is equals to x plus 100 by 25. 5 3s are 15, 5 5s are 25. So we have 5x equals to 3x plus 300. And therefore 5x minus 3x is 2x, which is equals to 300. And therefore x is equals to half of 300, that's 150 meters. So we have our answer as option B, 150 meters, which is the length of this train. A train 110 meters long is running with a speed of 60 kilometers per hour. In what time will it pass a man who is running at 6 kilometers per hour in the direction opposite to that of the train? Well, the formula for time is actually distance upon speed. Now we know that the man and the train are going opposite in their directions. Hence, the relative speed will be taken into consideration. So what is the relative speed when two objects are moving at an opposite direction? Well, it is just the addition of their speeds. So we have the speed as 60 kilometers per hour plus 6 kilometers per hour, which is 66 kilometers per hour. Now to pass a man which is as good as a point, a train will have to travel its own length, and therefore we get the distance as 110 meters. Now there is a difference in the units. We'll have to convert this meters to kilometers, or this speed which is in kilometers per hour to meters per second. Let's convert the speed. So this is equals to 110 meters, and we have 66 times 5 by 18 meters per second, and that will give you the time in seconds. So this is equals to 110 times 18 by 66 times 5. 11 6 are 66, 11 10 is 110, and then you have 5 times 2 is 10, and 6 times 3 is 18. So 2 times 3, and that is 6 seconds. So this is the time taken. Option B is the correct answer. Two trains 140 meters and 160 meters long run at a speed of 60 kilometers per hour and 40 kilometers per hour respectively in opposite directions on parallel tracks. In how much time the trains cross each other? Well, this is a pretty straightforward question. The two trains are traveling in opposite directions, which means that their relative velocity will be the addition of their speeds. So relative speed here is equal to 60 kilometers per hour plus 40 kilometers per hour, and that's 100 kilometers per hour. Let us convert it into meters per second. So it is equals to 100 times 5 by 18 meters per second. Now for the trains to cross each other, they will have to travel a distance of the addition of each of the train's length. So we have the distance as equal to 140 meters plus 160 meters, and that is equals to 300 meters. So we have the speed, we have the distance, we can calculate time. So time is equals to distance upon speed. So it is equals to, we have the distance as 300 upon speed is 100 into 5 by 18. So these two zeros get cancelled out. What we have is 3 times 18 by 5, and that's equals to 54 by 5, and that's 10.8 seconds. So the answer is option D. Two goods trains, each 500 meters long, are running in opposite directions. Their speeds are 45 kilometers per hour and 30 kilometers per hour respectively. Find the time taken by the slower train to pass the driver of the faster train. Well, this question is also similar to the previous question. It's just a play of words. What you have to find is the time taken by the trains to cross each other. So again, we have the lengths of the two trains as 500 meters long. So the relative distance traveled is basically the addition of the lengths of these two trains. So distance is equals to 500 meters plus 500 meters, that's 1000 meters. And the relative speed is the addition of the respective speeds because they are moving in opposite directions. So we have 45 plus 30 as the relative speed in kilometers per hour, and that's equal to 75 kilometers per hour. Let's convert this speed into meters per second, and that's 75 times 5 by 18 meters per second. So you have the distance, you have the speed. So time is equals to distance upon speed. So the distance is 1000 meters, speed is 75 into 5 by 18 meters per second, and that's 1000 into 18 by 75 times 5. Now 25 times 3 is 75, 25 times 40 is 1000. 3 times 6 is 18, and we have 5 times 8 as 40. So we have 8 times 6, that is 48 seconds as the time taken. So option C is the correct answer.